You're now under automatic control. Hands-off steering.
Tonight on Science Matters, this was the vision of the future, the driverless car. It just took a while to get here, but it is here, or at least it's just around the corner.
You can envision traffic lights eventually going away someday because cars could just space themselves out appropriately.
Also tonight, a science teacher decides that a place that was off limits when he was a kid makes a great classroom for his students.
For us, the Reservoir is kind of like an idea center.
And this 50-year-old marvel of design and engineering did not come with cleaning instructions or an easy way to figure out what those stains are.
I will tell you that we're very pleased with a lot of the results that we're finding.
It's all tonight on Science Matters. I'm Jim Kirchherr. We're here tonight to explore science and technology. Sometimes the complicated stuff, the breakthroughs, and sometimes the everyday stuff. Our stories will be from around here and around the country, from laboratories and factories, hospitals, schools, homes, forests and rivers, and just about anywhere we care to take a closer look. So we begin tonight at a very familiar spot on the St. Louis riverfront. The Gateway Arch has something of a problem. Figuring out exactly what's causing it involves laboratory analysis, electron microscopes, metallurgy. But before all that could begin, the first challenge was gravity. This wasn't just one of the more unusual sights of the summer of 2014. It was one of the most unusual sights of all time at the Gateway Arch. People climbing down the north leg and getting ready to get what you might have thought was an impossibly close look at the underside.
Our safety manager has referred to this project as Mount Everest.
Stephen Kelly is with WJE, Wiss, Janney, Elsner and Associates, a Chicago company that brought a team of scientists, engineers, experts, and members of the appropriately named Difficult Access Team.
Well, we're building doctors, and we're trying to do what we're doing is we're doing a very careful diagnosis of the building.
The arch is recognized for its simple, dramatic design and for the complex engineering involved in its construction. But for all the work that went into this and all the drawings and records that are on file, the Gateway Arch did not come with cleaning instructions. And about 20 years ago, the shiny stainless steel surface began to stain. And the question came up, is this dirt or is this damage? The National Park Service hired these folks to find out.
And at this point, we haven't done the analysis to have any firm conclusions, and that those are what we'll be looking at.
I am the stainless steel consultant on the project. We've also gotten samples of 5 of the wells to look at their condition.
The checkup of the 50-year-old monument began in 2006, and they spent a lot of time inside checking the conditions, condensation, things like that, and to see how the structure was holding up. Pretty well, by the way.
It's a very prescriptive process that's looking at the entire arch so that we can preserve it for future generations.
They'd already inspected the stains and graffiti at the base, but those stripy stains about halfway up, that might be something totally different. And to know what it is and how it might be cleaned, they need actual samples. For days, it looked like one of them was about to drop over the edge to do that. But nothing was going to happen until they got a favorable answer to this question. How's the weather up there?
And so we have a weather station at the top of the arch that is giving us real-time information, wind speed, gust speeds, temperature, and we're making decisions based on that information. And then how the wind direction makes a big difference as well.
And one day, it wasn't too hot or too cold or too windy, and the Difficult Access Team began the operation they had started planning 2 years before.
We're very safe. They're all very highly trained individuals who are doing the rappelling work. So I think it's not a question of safety when you're being safe and have the training. It's just a question of exercising good judgment and caution.
This was the same team that inspected the Washington Monument from the very top to the very bottom, looking at the cracks from an earthquake and all the stone blocks and the mortar between them. The information guided the repairs and restoration. It was pretty much the same thing here. Instead of bricks and mortar and cracks, it was metal panels and welds and stains.
And this is very, very difficult with the multi-angles and multi-planes, and use suction cups while staying on the rope to guide themselves down to take samples. And they'll use gunshot residue tape to take the samples.
We analyze those using scanning electron microscopy to identify the chemical constituents in those stains.
The laboratory analysis is still underway, but the Park Service will receive a report, a diagnosis, and recommendations for treatment.
I will tell you that we're very pleased with a lot of the results that we're finding. I really can't divulge what they are, but we're very pleased with the things that we're finding on the monument.
In other words, these are probably cosmetic issues. The arch doesn't need shoring up or serious patching, just a good cleaning.
Let's say the arch is going to be cleaned top to bottom. There'll probably be a cocktail of different cleaning methods that would be used.
But if it was this hard just to get to the spot to take a sample, how hard is it going to be to clean the arch, top to bottom or even here and there? On the Washington Monument, you could just build scaffolding all the way up and do the repairs. You can use scaffolding at the base of the arch legs, but further up, that's going to require a different, innovative solution. WJE will likely bid to be one of the consultants on that phase of the project.
It's Mount Everest for us to access the building to do the investigation, and it will be more Mount Everest when it is cleaned.
I wonder if now or down the road the cleaning might not be done by a robot, a flying robot, scrubbing mechanisms or brushes attached to a drone controlled from the ground. Drones are already here. They're not cleaning monuments or windows or delivering packages, not yet. But you've probably seen what they're already being used for. The drones made by a Florida company called Hoverfly Technologies are allowing us to see things like we've never seen them before.
When you see an aerial shot in a location where it would be difficult to get a full-size helicopter, there's a good chance that that shot was taken with our electronics. We're on National Geographic. We were just on Discovering the Mayans show. We're on Billy Hand Fishing. We're on Discovery Channel. We're on a lot of the shows that you've seen on television today. They use our systems. They can get very handheld, free-flowing shots on a movie set like a Steadicam, but then they can also bring it up like a jib, and they're not limited by the length of the jib. They can go up to several hundred feet, so they sometimes call it an infinite jib. And this is the Hoverfly Pro. It has 16 microprocessors, accelerometers, gyroscopes, and this essentially is the flight controller. It takes commands from the ground. They're very stable for putting a camera in the sky, almost like a tripod in the sky. It still requires a user on the ground to tell it where to go, tell it when to come down and go up. Typical application is within about a 500-foot radius with a ceiling of 400 feet. We started Hoverfly Technologies about 2 years ago, the 4 co-founders. It was started on kitchen tables and garages. We were all interested in embedded electronics using microprocessors and sensors. With today's technology used in cell phones like accelerometers and gyroscopes and barometers, we were able to use the high volume applications of those sensors with microprocessors and make a very clever piece of hardware that can control a multi-rotor aircraft.
You live long enough and science fiction becomes reality. Take cars, filled with computers and sensors for some time now. They can give you directions, they can call for help, they can even park themselves. And it's really only a matter of time before we won't be driving them at all.
Hey, I wonder what we'd hear if I'd turn on the switch and we're driving along in 1976.
This is a General Motors film from 1956 called Key to the Future, imagining a world that might be in 20 years. They didn't get everything right, but it is a world of limited access highways and a car with a dashboard where the gauges and meters have been replaced by a video screen. This happy family could get a map of where they were going and directions, but all of this was envisioned before there were any satellites orbiting the Earth or computer circuitry in just about everything. So this family was getting a lot of their help from a man in a control tower.
Firebird to tower. We'll take the green.
Roger. Check your fuel and engine.
Check.
And when they were ready to sit back and relax, this car of the future could drive itself.
Well done, Firebird 2. You're now under automatic control. Hands-off steering.
Mind if I smoke a cigar? Oh, not with this wonderful air conditioning. Hey, you want some ice cream or a cool drink?
Orange juice, please. Oh, me too.
I'm gonna go for the ice cream.
1976 came and went without driverless technology. But now, all of that is about to change. Google has already unveiled its prototype self-driving car and said this year it could be tested on public streets. This vehicle does not have a steering wheel or brake or gas pedals. You couldn't drive it if you wanted. But other car manufacturers, including General Motors, are working on their own versions of driverless, or what they're calling almost driverless cars. For more on that, we join PBS NewsHour's Hari Srinivasan in New York.
With advancements in auto technology, some industry leaders believe we're getting close to the Jetsons era of travel. It seems clear that driving will become increasingly automated in the next 5 to 10 years. In fact, legislation has passed in Nevada, California, Michigan, Florida, and Washington, D.C., allowing driverless cars on the road. Here with me now to discuss this trend is CNET editor-at-large Tim Stevens. So, you've actually been in a car that is just driving by itself. You went off to Sweden to do it,
right?
But it works.
Right. Sweden's got a pilot program with Volvo, of course, being kind of the national car company there. And they've got some highways set up in the town of Gothenburg, which is just outside of Volvo HQ, where you can basically go on the ring roads around the city, push a button on the dashboard, and the car takes over for itself. It'll slow down if there's any obstacles or traffic ahead of it. And it can even communicate with the city using wireless communication to know if there are lane closures or any other delays that it needs to make amends for, basically.
And this is just really their prototype. They say that this is their first step. They don't have a fleet of these running yet.
Right.
But eventually, they want to start selling cars that will do more and more of the driving for you.
Right, and Volvo says by 2017 they'll be selling these cars. And the interesting thing about Volvo's approach is that they're building this technology on sensors that are already in the cars today. We're seeing a lot of self-driving research out there from Google and from Mercedes and from Audi and a lot of other companies too. But a lot of those companies are really being built on a lot of sensors being built into the car. You see laser scanners on the roof and radar and all sorts of stuff that adds a lot of cost to the car. Volvo's technology is really simple, really cheap, and they think that they can basically build on top of that and just add a lot of smarts to the existing systems and do it for very inexpensively.
And I think mostly the concern for a lot of people is, what about the safety? We've got so many sensors on there. What if I'm in a bad hailstorm, electrical whatever, all this stuff fries out? Am I going to get into a wreck because the car can't compute?
Right, and that's a big part of the equation is how can the car hand control back to the driver at this point? This is a very important thing because the cars absolutely cannot drive themselves in every condition. In fact, Google's car has never seen rain. It's never seen snow. It's only been tested in perfect California conditions. That's one of the big challenges is seeing through snow, seeing through rain, and knowing how to react to it. So a lot of these car companies are researching ways to make sure that the driver is paying attention. So if the car does get into one of those situations, you can make sure the driver is looking at the road and then hand control back to the driver in a safe way, or if not, pull off to the side of the road and stop slowly.
Okay, so let's say best case scenario, we've sorted out the safety. What are some of the societal impacts here if we have a lane full of cars driving an inch apart from each other at 70 miles an hour and people are able to, have their coffee or read their paper?
So you can definitely imagine special lanes on the highway that have steeper off-ramps because you don't have to worry about stoplights and that kind of thing. You can envision traffic lights eventually going away someday because cars could just space themselves out appropriately and they could just crisscross all together. You can imagine parking garages that are a lot tighter in terms of height because nobody needs to get out of the cars, and they can be a lot tighter in terms of parking distance because you don't need to open the doors because basically the car will pull up, drop you off where you want to go, you'll hit a button on your phone, and the car will go park itself. So the car can go up and find a spot spot in a parking garage and basically just pack the cars themselves in so that if one car needs to get out on the other side, the other cars could just move out of the way, let that in, and then pack in again. So we can fit a lot more cars in the same spaces without having to build more garages and more highways.
And then maybe we wouldn't necessarily all need to own one vehicle. The vehicle could go out and service all the other people around while it's not driving for us, right?
That's the ultimate vision that a lot of people have, and ultimately I think that's what Google's really looking forward to, especially with their work with Uber. Basically, the idea is that once you're really just using a car to get from point A to point B, when you're saying at your phone, I need to go to work at this time, it doesn't matter if that car was sitting in your driveway all night long, just being idle. As long as the car's there in time to get you to work on time, who cares where it was that night before? Who cares where it is while you're at work? The idea of car ownership may be something of the past, as these cars can basically drive themselves.
Okay, so before we decide to shed our vehicles and get into this leasing agreement with this vehicle that's running around, in the intermediate term, there are kind of operating systems that are now working their way into our cars. I mean, we saw a little bit of it with the Ford Sync, but there's also Apple's getting into it, Google Android's getting into it. As a driver, I'm saying, do I need more things to distract someone while they're driving?
Ultimately, smartphones are very distracting, and people are unfortunately showing that they would rather be connected and use their phones while driving than be safe. Study after study shows that using your phone while you're driving is as dangerous as driving drunk, but yet people are still texting while driving. They're still, pulling up a Spotify playlist or something like that, which is unsafe. These systems are designed to make it much more easy to do that. So a lot of them are really heavily voice oriented, so you can speak to your phone and say, give me directions to this place, or have a text message read to you rather than having to try to see it on a screen. And that's basically the idea of Apple's CarPlay and Google's Android Auto and some of the other solutions that are coming out to give you some of the control over your smartphone without having to look at the screen, without having to try to type on a tiny little screen, and without being distracted. So if you are driving and trying to interact with your phone, you can do it in a safe way.
A lot of the in-car navigation systems in the past 10 years, they actually added a layer of distraction to drivers, where they would sit around and try to navigate a tiny mouse wheel here or there and try to pinpoint where they want to go. And I'm like, the whole time, hey, buddy, you're driving this huge 3,000-pound machine on the road, right?
And part of that was because the voice recognition in those systems was so primitive, because it had to be built into the car. Every word that you had to say had to be into the car, whereas now with our phones, basically, if you ever talk to Siri, if you're talking to Google, the phone isn't actually processing what you say. It's all going up to the cloud, and then they figure it out on some powerful server somewhere. When you add that kind of functionality to the car, you can do a lot more comprehensive things with your voice. And once you can say, give me directions to a really long address, or send a text message to my mom saying, hey, I'll be late for dinner, and the phone can figure that out for you, suddenly things get a lot easier and a lot less distracting.
All right, Tim Stevens of CNET, thanks so much.
Thank you.
Firebird, I'll swing you to the right. Hands on steering. Firebird, good night.
There are different ways of learning things. You can read about it in a book, you can get it from a lecture, or you can get out and do it. With science, especially with kids, that hands-on experience can make all the difference. It can make science more than a class they have to take, more than a test they have to pass, but something that is all around them. There are ways to make it interesting, relevant, and useful. There's this project in New Jersey. It was featured on our American Graduate Day broadcast last fall. It's an innovative approach to keeping kids interested in school and science by getting them out of school.
For me, science is something about discovery. And I've spent many of my younger years before I started teaching kind of exploring. I lived right by here, and my first relationship with the reservoir was a no trespassing sign. There's something wrong with the no trespassing sign when there's a place for kids to go to, and we kind of came up with an idea to start doing science here. It was saved by the Jersey City Reservoir Alliance, who we have partnered with, and we work with them, helping them with educational outreach, environmental education. For us, the reservoir is kind of like a idea center.
When it comes in like that, and maybe a lot of Project Reservoir is based in the classroom and based here at Reservoir number 3. So we were able to establish 2 different aquaculture rooms within the school. Teams are working on different aspects of environmental science. And there the kids develop their technologies. They find solutions to problems that they basically identify here.
This PVC pipe will also have some poked holes around the sides.
Robert O'Donnell is a great motivator. My skill set, I'm the mad inventor.
For example, the pump we have running at the reservoir now is from a boat.
It's good to have a team atmosphere, not only for the students, but also with the teachers. One of our emphasis with Project Reservoir is creating teams.
Currently we have 4 different teams in this year's 8th grade competitions, developing their projects for national competition. Some of the teams are working on different aspects of environmental science. Some you may see behind me here are some past chinampas that were built by previous members of the project. Now currently one is going to be modified into a floating tilapia containment system where we breed the tilapia within a lab, and we're testing their containment and their feeding trials, eventually for placement here per state approval.
And this year, one of the group of girls decided they want to work in composting.
So they're developing a solution to use compost as bait, given the fact it's releasing CO2 and heat to attract mosquitoes.
The aluminum makes the heat for the mosquitoes to attract, because that's what we want. That's our goal of our project.
Our team is called the Earth Filters. Basically, we made filters for people in need of water, so we try to clean dirty water through the filters that we created ourselves.
Technology has been changing, and we kind of adapt with it from year to year. We're doing websites, they do Twitter, they do Facebook pages.
And they have components of their project that may be developed by a specific manufacturer or company. So then the kids quickly realize, oh wow, we're using this in our prototype. Why not use Twitter or other social media sites to outreach to them, and then possibly get some sort of connection or some feedback from the company, just so the company could see that their product is being recycled into something that could benefit the environment.
I think one of the best things about the social media is the students are learning how to use social media in a positive way. One of the new technologies is 3D printing. We create prototypes, and sometimes when we're doing prototypes, we need a specific plastic part for what we're doing. So our idea is that we can use the 3D printer to build these small parts to integrate them with other recycled materials.
Kids currently, they're all looking to create apps, so that's something we're kind of looking forward to doing. And we have a partnership with an app-based company that gave the kids membership for the year or so. And again, we don't know how to do it, so we're just sitting in front of the computer and they're asking questions and we're saying, well, we're not sure. You basically have to look at tutorials and ultimately figure it out yourself. And within the last month, they've made some significant progress with that.
We have to keep up as teachers for the students to look for new things that we can incorporate in our projects. Looking forward at Project Reservoir, we need to look at how we can get it to be sustainable. And sustainable means the students from here take this to high school.
Hopefully I can carry it out in high school with the other members of my team. Once you start becoming mature in high school, you notice different things based on these sort of projects. So if I can start something like that in county prep, then that would be amazing, because I'd get more kids involved into the school and into the project.
Early exposure to science, lab work, I think really gives these kids an idea and a direction of something that they can do.
Being in the reservoir, the kids actually have real-life application to a lot of the science concepts that they learned. And I think that, having Rob there and Joel there guiding them into this science facts and making it come to life, I think that's what the Project Reservoir brings.
When I hear stories of these students saying, I'm going to be an engineer, or a parent asking, can my son be an engineer? Those are things that I know, there I go, I can't quit. I'm going to be stuck doing this for a while, because those are things that I know as a teacher are very important for their success further on.
I think STEM-based activities, put the kids in control of what they want to be done and what they foresee in their environment and the change they want to make in it. To have those experiences is beneficial and crucial for the development of the kid, and I think it's a great way to connect the child or the group of kids to that topic, and then from there they develop that spark, and then once that spark is ignited, they could take that and use that to ignite the rest of their future.
You let kids see things and do things, and you never know what impact it's going to have, what seeds it's going to plant. We wrap up tonight with a story about just that sort of thing, and it takes us back to where we started tonight, the Gateway Arch. When we were talking to the team that was working on taking those arch stain samples, the team leader told us about something that happened when he was a kid, and his parents brought him to St. Louis. So after we got all the information about the chemical and metallurgical analysis, I asked Stephen Kelly to tell us that story.
I'm from Decatur, Illinois, which is about, 70, 80 miles from here. And I was raised a Cardinals fan. And we used to come down to St. Louis to ball games. And when I was 10 years old, we came down and both legs were coming up, and we got up in the viewing stand, and I took some chromey black and white photographs with a little box camera, which I still have. And later we came down again and we saw the movie The Monument to the Dream, which is an excellent movie, by the way. And it made me think that I wanted to be an architect, that I wanted to build things. Now, I'm a preservationist now and I work on heritage monuments, and for me to be here now working on the Gateway Arch is just really wonderful. It's kind of like life has come full circle for me. I'm really glad to be here, and I'm really happy to be working with such talented people, not only people on my team, but with the National Park Service, because they really care about the monument as well.
Did you ever think you'd be poking your head out that top door?
No, well, I didn't know there was a top door. But no, I didn't think that I ever would be.
And that's tonight's Science Matters. Thanks for joining us. I'm Jim Kirchherr, and we'll see you next time.